My name's Troy Kling, and I'd like to introduce you to one of the project ideas for STEAM and AI's Winter 2023 cohort. This project will focus on using topological data analysis to quantify election polling site coverage in certain cities. Here we have a zip code in Atlanta, Georgia. The red dots indicate actual polling sites there, and the green path indicates the shortest path between two such polling sites. One question you could ask once you have access to this data is this equitable coverage? And one way you can start evaluating that is with persistent homology, a cutting-edge tool from topological data analysis. So in this toy example, let's imagine I have these 10 polling sites. What persistent homology does is it gradually expands circles around those polling sites until said circles intersect, at which point you introduce a line segment between them. And if three such polling sites ever intersect, you introduce a little triangle between them, and you start to see structure forming as time goes on. Especially at this point, you start to see that some structure has formed, and if you happen to live in the center here, you're in a gap for polling site coverage, right? That indicates it would take me longer than people in other regions to travel to my nearest polling site, and indeed that gap doesn't get filled for quite some time. So sitting down and quantifying when that gap forms and when it dies gives us an interesting way to quantify underrepresented regions or regions in need of more voting booths. Actually, you can sit down and do this for Atlanta, and you can see that here are 5 of the worst regions for election polling site coverage. And indeed, if you compare Atlanta to Chicago, you can see that Atlanta's far worse off, that the wait times, on average, are quite a bit larger, sometimes going up into multiple hours for Atlanta. So, if you're interested in learning more about this, I would encourage you to apply to STEAM and AI's Winter 2023 cohort, and we'll get to work on some very fun stuff together.